Hello, my name is Zachary, a member of the security team. Today, our team will provide a cyber operations and risk management briefing. Hanna will identify the software assurance needs and expectations of the organization, as well as describe key attributes of the software development lifecycle. I will identify known supply chain risks and software vulnerabilities. Ruth will present and recommend the software options that meet the organization's needs. William will evaluate the supply chain options and the costs associated with each recommendation. And finally, Tara will brief the recommended contract language to ensure that the supply chain, network, and operational security requirements are met.
The key attributes of the software development lifecycle, SDLC, is defined in 6 phases. The phases are arranged in a priority sequence and represent the passage through time of the software development. The 6 phases in every SDLC model include planning, analysis, design, implementation and deployment, testing and integration, and maintenance. Planning phase defines scope, acceptance and exit criteria, it identifies risks, it is secure funding. Analysis phase capture and document requirements, define product features, assess impact of change. Design phase identifies software features and characteristics expected for the end user's experience, and it is solution specification. Implementation and deployment is the start of production. Developers code according to the software requirements. Organization will focus on training during this period of time. Deployment plan. Testing and integration. Execute test cases, capture test results, resolve test defects. Maintenance. The software is continuously monitored for any development issues. Developers will disseminate patches and update as necessary. Software assurance includes the development and implementation of methods and process for making sure that the software is functioning as planned while reducing the risks of vulnerabilities or defects that can harm the end user. Many business actions and critical functions depend on the accurate operation of the software. Therefore, software assurance is vital to confirm that critical IT resources are protected. The main purpose of software assurance is to modify the security model from patch management to software assurance. This modification is intended to inspire software developers to advance the quality and security of the software from the beginning of the software lifecycle, and instead of applying patches to systems after finding vulnerabilities. The software assurance risks faced by users today can be categorized in 3 areas. First is accidental design or implementation error that lead to exploitable code vulnerabilities. Second one is the changing technological environment, which exposes new vulnerabilities and provide adversary with new tools to exploit them. Third one is malicious insiders who seek to do harm to users or vendors. Industry should apply best practices throughout the life of the software to improve software assurance and security. Developers should be trained in assured software development practices. Software managers should be trained to have a better understanding and advocate software assurance. Software assurance should be treated as required, integrated part of the software development lifecycle process, and software assurance should be included in program reviews for projects that require developed software.
Hello, my name is Zachary, and today I will be covering the risks and vulnerabilities of the software supply chain. A supply chain contains all of the components from creation to the end final product. Each chain in the link is a supplier or external service provider. As shown in the sample diagram, each supplier may have their own set of suppliers and service providers. In order for the organization to operate efficiently and effectively, each supplier in the chain must fulfill their requirements. Deficiencies lower in the supply chain can create negative impacts all the way up through the chain. Adversaries are using this strategy to inject malicious ransomware in the lower levels of the supply chain. The suppliers unwittingly pass the malicious code up through the entire chain. In this way, attackers can breach the security of hardened organizations through the trusted supply chain. The organization takes its software from a multitude of third-party companies who incorporate additional third-party components in their software. The security team must scrutinize and be aware of software risks and vulnerabilities throughout the entire supply chain. However, it becomes more challenging and time-consuming to inspect further down the supply chain. Supply chain vulnerabilities can be external or internal. External vulnerabilities are weaknesses within the entities of the supply chain. Internal vulnerabilities are deficiencies within the organizational policies and processes or information systems. Internal and external vulnerabilities are not separate and go hand in hand. Following through on strong organizational policies and procedures will identify and mitigate external vulnerabilities in the supply chain. The supply chain faces adversarial and non-adversarial threats. Adversarial threats come from attackers motivated by malicious intent. Malicious software, such as ransomware, falls in this category of adversarial threats. Non-adversarial threats can be just as damaging, but there is no malicious intent behind the threat. Poorly designed and tested software threatens the supply chain equally. Should the threats capitalize upon the supply chain vulnerabilities, the data and system components could become compromised or unavailable. Depending on the severity of the attack, a full recovery may be impossible. Therefore, hardening vulnerabilities and remaining vigilant against adversarial and non-adversarial threats is a necessity for survival. This figure illustrates how information technology, operational technology, threat actors, and threat methods are connected to one another. All threat methods should be taken into consideration, but ransomware right now is the most relevant given the current security situation. The motivation and sophistication of the attack will change depending on the threat actor. The motivation of the attack will determine the primary risks to the supply chain. Successful attacks could lead to the physical disruption of services, a breach of privacy, or a breach of intellectual property. Protecting the software supply chain from beginning to end will help prevent data breaches and system disruptions. In order to identify and mitigate software vulnerabilities, the security team used relevant software control families from the National Institute of Standards and Technology, or NIST. The two relevant control families are 1. System and Information Integrity, and 2. System and Services Acquisition. Both control families cover vulnerabilities from adversarial and non-adversarial threats. Each control family has numerous controls, but the security team picked the top 3 for each. For System and Information Integrity, the controls are flaw remediation, malicious code protection, and software, firmware, and information integrity. Flaw remediation controls ensures flaws are identified and remediated within a prescribed set of time. It automates patch and firmware updates while clearing the system of outdated versions. Malicious code protection automatically updates signature and pattern definitions. Only privileged users can perform updates to establish more control and scrutiny over software. Malicious code protection can detect and prevent execution of unauthorized commands. Software integrity validates the validity of approved software. This prevents attackers from injecting malicious code inside approved software, such as ransomware. System and services acquisition focuses more on the supply chain components. Engineering principles prioritize security as a foundation of design instead of an afterthought. Secure design must be incorporated into software life cycles. Supply chain protection ensures that vendors are vetted and reviewed. The software supplier must be able to provide visibility, authenticity, and traceability of provided software and services. Lastly, incorporating tamper resistance and technologies ensure that the validity and authenticity of provided services and software. Tamper-proofing software can be achieved through digital signatures, cryptography, and access control.
Hello, today I'll be covering the section on identification of software options that could meet the organization's need and evaluation of software options and recommendations. After doing an extensive research and comparing the top 15 supply chain management software, the fair team came up with three software options, which are the SAP, Epicor, and Velocity. The choice was made based on the features and deployment keys such as inventory management, logistic transportation, warehouse management, order and billing management, supplier collaboration, real-time visibility, and platforms and cost of the software.
All right, good evening. My name is William Ward, and as Ruth was discussing earlier in this presentation, the top three recommendations for our supply chain management software are SAP, which is the ERP supply chain solution, Epicor supply chain management, and Velocity control tower platform. Some of the key features for all three of these include inventory management, orders and billing management, logistics and transportation, supplier collaboration, warehouse management, and real-time visibility. One significant difference with these three is Velocity Control Tower Platform is the only one of these softwares that is solely software as a service. The other two, Epicor and SAP, which is the ERP-based supply chain solution, require some form of on-premises technology housed by the customer, which is fair dinkum in this case. For those of y'all that don't know what ERP is, I'll break down SAP a little bit for you on the cost. ERP is the Enterprise Resource Planning. And it's a large-scale software program designed for modern businesses. That's large and small. Businesses such as Ford, GE, IBM, they all use programs such as SAP, which are ERP-based supply chain solutions for their organizations. ERP systems are priced on a per-user basis, specifically the number of users that will be required to use this system and this service at the same time, and the level of access that they require whenever they're using this service. You can expect to pay within anywhere from $1,500 to $4,000 per user in this service. Fair dinkum is relatively small. We have about 5 users, so it still wouldn't be that much, but where we can expect to get hit is on the annual renewal cost for SAP. Small businesses generally pay about $10,000 to $150,000 for an ERP-based service. And other organizations other than SAP lower the implementation cost but charge a higher renewal cost. SAP does not lower the implementation cost, but they still charge the high renewal cost. The cost breakdown for all three of these is approximately 5 to 10% for database management, 10 to 20% for infrastructure costs. The software cost is about 15 to 30% of the cost breakdown, and human resources is about 40 to 60%. In this case, all three of them do the exact same thing. And Velocity, which is the only one that is solely a software as a service, does not require additional cost for implementation because there's nothing that we need to buy to begin getting full access to this service. So as Ruth stated earlier in this video, Velocity, it does everything that the other two softwares can do. We're not a large-scale organization, so we do not need something such as SAP that can that can hold 1 million users at once. So Velocity seems to be what we would need as the cheapest and most viable option.
So what we're going to be discussing are the recommendations for contract language that would be used to ensure supply chain systems, network, and operational security were met. This is going to include defining roles and responsibilities, requiring security provisions, and acquisition lifecycle. So first I will discuss how a team-based approach to product and service procurements will improve acquisition throughout DTL Power. So the first role is going to be the Chief Information Officer. They're going to ensure that requirements and other applicable regulations and policies are going to be met for all acquisition and maintenance contracts. After that is the Information System Security Officer. They're going to ensure that appropriate safeguards are incorporated into the staffing, design, specification, development, testing, and acceptance of these systems and related service. Another person on the team is going to be the contracting officer. So they're going to ensure that appropriate requirements are accurately specified, funded, and enforced for all acquisition, operation, maintenance contracts under their supervision. And finally is the technical officers. They're going to lead the development of the sensitivity assessments for the systems and data associated with the contract, ensure that the appropriate levels of protection are applied to the contract. So the next step after creating this team is going to be requiring security provisions. So information system security must be addressed in all contracts that include information technology resources or services in which a contractor must have physical or electronic access to sensitive information that directly support the DTL Power's mission. So now we're going to talk about the acquisition lifecycle that is integrated into the contract language. So first is the planning phase. So during the initial planning phase of the acquisition cycle or task order development, the definition of the security requirement for the product or service being procured should begin with the systems and organization control, so SOC report review. So what this is going to do is going to measure whether they are applicable to DTL Power's user considerations. So what security measures do we have in place, and do they follow the security measures that we want in our organization? And then after that is going to be the requirements analysis. So these analyses represent a conceptual framework for planning and ensuring that operational and security requirements are addressed accurately and in sufficient detail.